continuing with our series, giving an overview of epidemiological study designs. And in this second part of our series, we are looking at an epidemiological study design that is called cohort studies. We start with a case study. Dr. X set up a study in which he followed 1,000 children who were malnourished in childhood and 1,000 children who were well nourished. And he wanted to assess their eventual academic performance when they started primary school. His hypothesis was that children who are malnourished in early childhood would eventually perform poorer in school than those who were not malnourished. And after following the children for 10 years, he assessed their overall performance in exams and determined that the risk of failing in either, and determined the risk of failing in both groups, that is, those who had been malnourished and those who had not been malnourished. And he was concerned about the proportion of children that were lost to follow-up. So among other concerns, he was concerned about the proportion of children that were lost to follow-up. But he was also concerned that this study became a little bit costly, especially following up these children over 10 years. So this typically is a cohort study type of design. So let's look at cohort studies then. What is the definition of a cohort? A cohort means a group of people who share a common experience. Either they live in the same environment, or they stay in the same geographical region, or they share the same school environment, things like that. So a cohort means a group of people who share the same experiences within a defined time period. They are also called follow-up studies, or incidence studies, or longitudinal studies. Examples could be a birth cohort, that is a group of people who were born in the same year and then they moved through life together. A marriage cohort, a group of people who were married at the same time and then moved through marriage. A class cohort, people who were in the same class and moved through the years. It could be workers in a mine, working in a mine, so it could be different things. The key word is a group of people who are sharing the same experiences. Now, what then is the design of a cohort study? Cohort studies test hypotheses of causal associations between exposures and disease. So we have a disease, but with a health-related event for that matter. But then we have exposures. We have several, one or more exposures. We have things that we think cause this particular health-related event or a disease. So cohort studies study the association between suspected exposures and disease outcome. So this is how a cohort study is conducted, and you can look in the diagram on your slides to further understand the design. So we select a group of disease-free but exposed individuals. So we get people who are exposed to a particular exposure of interest, but they don't have the disease. And then we get a group of people still who don't have the disease, but they are not exposed to the exposure of interest. Now, we follow up the two groups for a period of time, and then we compare the incidence of the event of interest, either the disease of interest in the group that was exposed and the group that is not exposed. Let's take an example. If we want to determine the association between an exposure like smoking, so the exposure is smoking and the outcome is lung cancer. So what we do is that we get a group of people without lung cancer but who smoke, so we get smokers, and then we get people who do not smoke and do not have lung cancer, and these are non-smokers. So these are exposed. They're exposed to cigarette smoke. These are not exposed. So we follow these groups over time, and in each of the groups, we determine the incidence of cancer, of lung cancer, in each of these groups, and then we compare the incidences. Now, the important features in the design of a cohort studies are as follows. We, first of all, have to have a hypothesis about the relationship between the exposure factors and the disease. These hypotheses are determined from earlier studies that are mainly observational, cross-sectional studies. So we do some cross-sectional studies, we observe, and then we come up with hypotheses. Before then we test these hypotheses. Now, at the beginning of the cohort study, the persons who are studied, that is both the exposed and the non-exposed, have not yet developed the disease. And the exposure should be known, the exposure of interest should be known and should be measurable. So we should be able to determine whether someone smokes or does not smoke. And the two groups come from the same mother population. So we get people from the same population so that the findings can be generalized to that population. Cohort studies follow up people for years, sometimes going for several years. So we follow up people. We select people based on the exposure status and we follow them up. And then this design is quite useful in proving causal relationships, that this thing causes this. Because we start with people who are disease-free, who are exposed, and then we follow them, and then we observe for the outcome. Cohort studies are observational. We observe people in their natural setting without any manipulation, because if we manipulated them, it might constitute ethical problems. For instance, we cannot forcefully expose people to a negative agent. We can't tell people that, please start smoking so that we see whether you develop lung cancer. Or we cannot tell people that, please drive very fast so that we see whether, or don't put on your seat belts so that we see whether you are at higher risk of road traffic accidents. So in cohort studies, we just observe events occurring in their natural setting. Cohort studies are classified as analytical because we compare things that are happening in two groups. Now, here are some issues further issues about the design of cohort studies. How do we select study populations in cohort studies? There are two ways. We can select a study population on the basis of whether they are currently exposed or not. For instance, we get people whom we know currently smoke and people who do not smoke. Or we can select a population by screening for their current exposure status. For instance, the exposure status might not be obvious, so we need to screen for it to determine if someone is exposed. We might need to take histories. We take a history and we ask them, what are you doing? What are you experiencing, in order to determine the exposure. For instance, if the exposure is a psychological issue or a mental issue, we may not see it with our eyes, but we need to ask questions. Or we could do laboratory measurements to assess exposure for those exposures that are not obvious, but in the blood or in the biochemical makeup of an individual. Or we can even select people before they are exposed at all by anticipating their exposure. If I know someone is going to be exposed in the near future, I can select them in advance because I know for sure that they are going to be exposed. For instance, if they are planning to set up a chemical plant in a neighborhood, I could select a population even before they set up the chemical plant, so that by the time they establish the plant, that's when the exposure starts. I've already selected this population. Now, after selecting, we separate the population into those who are exposed and those who are not exposed. Now, we shall look at different types of cohorts. We said that cohorts are forward-going in time. I select a group of people who are exposed and a group of people who are not exposed, and I follow them up in time. However, This can have different configurations, and there are three types of configurations. There's what we call concurrent cohorts or concurrent prospective studies. There's what we call retrospective cohorts or historical cohorts, and then a hybrid of the two designs that we call ambidirectional cohorts. And what's a concurrent cohort? Simple. A concurrent cohort, in a concurrent cohort, we select a population and we characterize it on the basis of exposure at the moment. So we look at exposure at the moment. So I select a population and I say, I characterize them into exposed. So I divide the people into two groups, exposed and non-exposed. And the time is now. So I said I characterize them, then I follow them from now going into the future. So I follow them going into the future. And then I determine the incidence of the outcome of interest in the exposed and non-exposed groups. So these are called concurrent prospective studies or concurrent cohorts. The follow-up time starts now and goes into the future. But they have some disadvantages because they can be very long. For certain outcomes that take long to develop, even the researcher may, without seeing a significant number of outcomes, may be way outlived by the cohort. And they are quite expensive. They are also associated with a lot of loss to follow up. Now, for the retrospective cohorts, in a retrospective cohort, the main difference is the design is the same. I select people who are exposed and those who are not exposed, follow them up. But I shift the time frame to the past. So I say, so imagine that this is now. So this is now. This is 10 years ago. So I'm here in the now. So I look backwards. I ask, who was exposed 10 years ago? And who was not exposed 10 years ago? And then I start looking through this period up to now. Who developed the outcome of interest? And then I even go into, so I look through these 10 years up to now. So through these 10 years, I'm looking for who developed the outcome of interest. So that is a retrospective cohort. It is still a follow-up study, but the time for initiation has been shifted into history. And where do I get this information about outcomes? I get it from records, from, for instance, medical records or from employee records. And I look up to now, where are they in terms of developing the outcome of interest. So that is a retrospective cohort. The third type is a hybrid of the two designs, which we also call ambidirectional. So I look 10 years ago or several years before. I select people who were exposed several years ago. I follow them up to now, but I don't stop now. I continue following them into the future to see those who develop outcomes of interest. So I go beyond now and go into the future. So that's a hybrid of the two, and that's what we call the ambidirectional cohort. So this is the diagram that you see summarizes the three designs of cohort studies. Now, what are the potential biases in cohort studies? There are biases in assessing the outcome. The person reading the outcomes may be aware of the exposure status. So they know that this was the group that was exposed, and they tend to probe for more outcomes in that group compared to the other. There's also what we call information bias, especially if the quality and the depth of information obtained is different for exposed versus non-exposed groups. Remember that as you follow up, you're looking at records. You're looking at records to see what are the outcomes, what happened to these people as we moved forward in time. So if the information is not properly recorded, then you are likely to get quite a number of information biases. There's also non-response and loss to follow up. So people may get lost. They may move away from your study population. They may disappear. You cannot trace them. But there's also analytical bias, like a strong preconception in the epidemiologist or the statistician who is analyzing this data. They may be biased towards looking at a certain group differently from another group, and they may look for outcomes that do not exist. So that analytical bias, or they may probe more in one group compared to the other. Now, how do we analyze cohort studies? It comes from the design that we start with exposed people and non-exposed people. We follow them forward in time. We determine incidence in the exposed and non-exposed groups, and then we compare the incidence in the two groups. And remember that incidence is the same as risk, so we compare the risk between the exposed and the non-exposed. We use a measure for comparing risk that is known as the relative risk. So the findings from a cohort study can be summarized in what we call a 2x2 table. In a 2x2 table, on one side you have the exposure status. You have people who are exposed and people who are not exposed. And then on the other side, you have people who have the disease and people who don't have the disease. So you have a category of people who are exposed and they have the disease. Let's denote those A. And then you have a category of people who were not exposed. They were not exposed to the potentially harmful exposure, but they go on to develop the disease still. Then we have those who are exposed, but they don't develop the disease, and those who are not exposed and do not develop the disease. So if we denote those with those letters, we can then determine the incidence in the exposed, which according to this diagram is given by the people who are exposed, that is A, over the total number of people, the people who are exposed and developed disease, that is A, divided by the total number of people who are exposed. So it's like a proportion of the exposed that actually developed the disease, which is A over A plus C. So this is the incidence in the exposed. And likewise, the incidence in the non-exposed, the total non-exposed is B plus D, and the proportion of those with the disease in the non-exposed is B over B plus D, which is the incidence in the non-exposed. And then we can compare the two incidences, as we shall see later. What are the advantages and disadvantages of cohort study designs? So the advantages of cohorts is that the suspected causal factor, that is the exposure, is known for each subject at the beginning. So there's no selection bias. We know that this person is exposed and this one is not exposed. Two, it's most appropriate to study rare causes, that is outcomes from rare exposures that are not rare, that are not common. It's also useful to investigate multiple effects of an exposure. So you can study several diseases that come out of an exposure. For instance, you can follow smokers and you study the incidence of cancer, the incidence of chronic lung disease, the incidence of various things, of high blood pressure. So you can study several outcomes at the same time. And it is easy to calculate the risk of developing the disease. So you can determine the risk in exposed and the risk in non-exposed. And it's very useful in measurements of not only incidence, but also rates with which disease is occurring. The main disadvantages is that it is difficult to investigate diseases that occur rarely. If a disease takes 10 years, 20 years, 30 years to develop, you'll wait for a very long time before you have sufficient numbers of cases, and you need a very big sample size. It's difficult to investigate slow developing diseases. It's expensive, it takes time, it takes money, it takes personnel, and there are quite a number of laws to follow up. So several of your people disappear before you know what happened to them eventually. And there are also potential biases in assessing the outcomes. Like we talked about analytical bias. The investigator might have biases in measuring outcomes, and these biases could differ from one group compared to the other, and there could be difficulty in identifying comparable cohorts, comparable groups of people that can be studied. When do we use a cohort study design? We use a cohort study design when there is good evidence that a certain exposure is associated with a certain disease or health-related event outcome. When we are able to minimize loss to follow-up, because we know loss to follow-up is quite a big problem in cohort studies. When the interval between the exposure to the disease is relatively short, like it doesn't take too long to develop the outcome of interest, or when there is a complete recording system for important events, that is exposures and outcomes. So this makes it possible to do historical cohorts. And when there are comparable cohorts of exposed and non-exposed people that can be easily found. So in summary, these are some basic principles regarding cohort study designs. Thank you very much. In our next series, we are going to look at another type of epidemiological study design that is called case control studies.